Hello, in this video we'll be going over some basic trig integration. Oh, well, not trig integration, inverse trig integration. So all these problems in this video have been taken from the Specialist Mathematics textbook from Cambridge, units 3 and 4. So down below, here's all the questions we'll be doing. We'll be doing it from chapter 7b. In this video we'll be doing question 1, and in part 2 we'll be doing questions 2. So this main video is basically going over these integral forms and basically how to integrate these ones. I think these are pretty basic ones, but we'll be going over all the questions in depth. So you don't need to know where this basically comes from, but I will include a proof in a later video. But today's video is mostly just questions on this stuff. Alright, so let's get started. So if you see basically an integral in this form, it will be a sine inverse integral. So we'll just start with question 1. So if you have this integral, you have the integral of 1 over the square root of 9 minus x squared dx. When you integrate this, it will give you a sine integral pretty much, because it takes the form of this. So in this integral, we can look to solve this. We gotta know what our a value is. So our a value is basically any number. So in this case, a squared is going to be 9. Therefore, square rooting it, a is going to be 3. So when you integrate this, the integral of 1 over the square root of 9 minus x squared dx is going to be equal to sine inverse x over a, which is 3, plus c. Alright, so that was question 1a. We'll be going through, if you want to pause to try these questions before you do it. This is included on the Queensland data sheet, but they won't always take this form, so you might have to fudge them around pretty much. Alright, so that was question 1. I'll write up question 2 and then we'll go through it. Alright, so B, integrate this. If you want to have a go at this, feel free to pause the video and have a go. Alright, just from looking at this, it's going to be a tan integral. So we've been given so for a tan integral, you need to basically you need to have this form, a over a squared plus x squared dx, to be equal to tan inverse of x over a plus c. However, we don't have an a on the top because we just have 1. So if we want to solve the form, the integral of 1 over x squared over a squared plus x squared dx, and they've divided this whole integral by 1 over a pretty much. So it had a up there and that cancelled out. So this form would be 1 over a tan inverse over x over a plus c. So just rearranging this, all they've done is pretty much they've taken this form here and they've just divided by 1 over a. So you have to do it on the other side, pretty much. And then it will give you this form here. So solving this integral, we have to take a look at what our a is. So our a squared value is 5. Therefore, a is going to be root 5. So since it takes this form, we need to go 1 over a, which is root 5, tan inverse x over a, which is root 5, plus c. Cool. Alright, let's try another example. Integrate the integral of 1 over 1 plus t squared dt. Feel free to pause the video and have a go. Alright, so this is another tan integral. So since a squared is 1, a is also equal to 1. So this integral is just tan inverse of t plus c. Cool. Alright, so these are pretty easy integrals. right now. I'm just gonna move some stuff around so we have more space to write, because we're gonna have a more complicated integral in just a second. Just gonna select this. I'm just gonna move that out of here. Cool. So we just have more space to write. Alright, question 1D. Whoops. Alright, question 1D. Have a go at this one. The integral of 5 over the square root of 5 minus x squared dx. Alright, all we gotta do is, we've got a constant up here, all we gotta do is take the constant out the front, and it's a very familiar integral. So our a value, a squared is 5, therefore a is equal to root 5. Hence, our integral, when you integrate the integral of 1 over 5 minus x squared over the square root is equal to sine inverse of x over root 5. But we have a 5 here, so we need to have a 5 here. Sine inverse of x over root 5 plus c. Alright, cool. Alright, let's try another one. A lot of these inverse trig integrals pop up in partial fractions, which, yeah. So we've done up to D. Have a go at E. So feel free to try this integral for yourself. Alright, so same thing, we got a random constant up here, so we'll just put it out the front. So we get 1 over 16 plus x squared dx. Just from looking at this, we can tell it's going to be a tan inverse, because it takes the form, because it's got x squared on the bottom, but it doesn't have a square root over the top. So we're going to go x squared is, no, not x squared, I mean a squared, sorry. A squared is 16, therefore a is 4. It doesn't have an a at the top, so we need to divide by this a value. So we'll go, it has to go 3 times by 1 over our a value, which is 4. Tan inverse over x over our a value, which is 4, plus c. So therefore it's 3 over 4 tan inverse x over 4 plus c. Alright, cool. I'm now going to give a an obvious one now. If you can't tell, this video is more just about doing problems. It's not really about teaching it, because I feel like the best way to understand something is to teach it and to do problems. So problem after problem. That's how I learnt mathematics. So let's have a go at this one. So this is f, the integral of 1 over the square root of 16 minus 4x squared dx. Alright, this one's a bit different, so pause the video and have a go at this one. Alright, so we can tell this is kind of got the it's kind of got the look of a sine integral. So recall that the integral of 1 over the square root of a squared minus x squared dx is equal to sine inverse over x over a plus c. We've got to basically make this whole thing look similar to that. So the way we're going to do that is we basically got to get rid of this coefficient here somehow. So we're going to take our integral down here. So go 1 over the square root of 16 minus 4x squared dx. The way we get rid of it is basically we're going to factorize in here. We're going to take out our 4 out. So we're going to change how it looks. So just rewriting it. So I'm going to take a 4 out here. That's going to leave us a 4 here. And that's going to leave us with, yep, pretty much that. So now we have that bit. Recall if you have a surd, so let's say we have a square root of a times b. That's the same as the square root of a times the square root of b. So that's just a simple surd law. So applying this law in here, we can go the integral over 1 over the square root of 4 times the square root of 4 minus x squared dx. Square root of 4 is 2, and we can take the 2 out the front, so we go a half over the integral over 1 over the square root of 4 minus x squared dx. Alright, that looks a lot more appealing, and it looks a lot more like that. So now we can basically just do our sine rule, our sine inverse. So we go a half, and integrate that is, so our a squared is 4, therefore our a is 2. So this is going to be a half sine inverse x over 2 plus c. And that is the answer to this integral. Alright, that one was a bit trickier because you had to basically change how it looked. And the simpler ones we did before, they most likely will not appear on a specialist exam because everyone can get them right pretty much. You don't even really need to know math to basically do some of these integrals. You're basically just going to really know the form and plug in some of the numbers. But ones like f here take a bit of critical thinking, which will difference whether you pass a question or fail a question. So we're going to do a couple more similar to f now. Alright. Actually, we'll just do g now. So g, integrate this. dt. Alright, feel free to pause the video and have a go at this. Alright, first thing we're going to do is going to take our constant out the front, so the integral of 1 over the square root of 10 minus t squared dt. This is a sine, pretty much, because it's got the same form, so our a squared is 10, therefore our a is the square root of 10. Therefore, when you integrate this, you get 10 sine inverse 1 over a, so it's t over root 10 plus c. Don't forget your plus c or you won't get the mark. Alright, that was another simple integral. This is a very fast-paced video because a lot of these ones are pretty easy to solve. I'd say inverse trig integration is one of the most easiest forms of integration I've ever seen. It's basically know the rule and plug in the a's, pretty much. So I feel like the best way to understand the skill is just to do a heap of them. You can pause the video and have a go at the problems. That's why I'm going super fast, because I don't think there isn't a need of a lot of explaining for a lot of this stuff. And the proof for these integrals will come in a later video. So this is just a problems video pretty much. So let's have a go at h now. So the integral over 1 over 9 plus 16 t squared dt. Right, this one looks a bit interesting. So feel free to pause the video and have a go. Alright, so this one is not in the normal form. So we got to get this have a coefficient of 1. So we're going to do the same thing. We're going to factorize it. So the integral over 1 over, take out 16 here. So if you factorize here, you'll get 9 over 16 plus t squared dt. Because if you multiplied that in, that would give you 9 here and 16 here. So we can take the 1 over 16 outside the integral. So we get 9 over 16 plus t squared dt. Alright, a squared is 9 over 16. Therefore, our a is equal to 3 over 4. And recall, we don't have an a up here, so we're going to have to use this form, 1 over a tan inverse over x over a plus c. So 1 over a is going to be 4 over 3, and we have the 16 out the front, so times by 1 over 16. Tan inverse over 4 over t over 3 plus c. 4 times 1 is 1. 16 times... actually, we're going to do some cross multiplying. So 16 is 4 squared. So I'm just going to change that 1 over 4 squared times by 4 over 3. Cancel that. And so it's just going to be 4 times 3 equals 1 over 12. So the answer to this integral is 1 over 12 tan inverse 4t over 3 plus c. Right? That's probably as tricky as it gets for trig integration. Inverse trig integration. Trig integration, it uses a lot of rules and it's a lot more complicated. I'll be doing a video on that pretty soon, and I'll also be doing a proof for a lot of these integrals. Alright, let's have a go at I now. So have a go at this one. So go I, the integral over 1 over the square root of 5 minus 2x squared dx. Alright, feel free to pause the video and have a go at that. Alright, so obviously it's a sine integral because it's the integral 1 over square root of a squared minus x squared dx is equal to sine inverse over x over a plus c. It's got that very similar form, but obviously it's not exactly, otherwise we'd just be able to plug straight into the formula. Alright, so we're going to get this to have a coefficient of 1, so what do? We factorize. So the integral 1 over square root, take the 2 out, 5 over 2 minus x squared dx. Alright, now we're going to use our third law. So recall, if you have the square root of a times b, that's the same as square root of a times the square root of b. So what we do is integral over 1 over the square root of 2 times the square root of 5 over 2 minus x squared all over a square root over the fraction dx. Alright, we can take the 1 over the square root out the front. So the integral over 1 over the square root of 5 over 2 minus x squared dx. This has got the same form now as our trig integration up here. So therefore a squared is equal to 5 over 2. Therefore a is equal to the square root of 5 over 2. Or you could just write it like square root of 5 over the square root of 2. Doesn't really matter. Therefore our integral is 1 over square root of 2 sine inverse 1 over a, which is square root of 2x over the square root of 5 plus c. Alright, we got one more integral, don't we? Yeah. So last integral of the video. Again, these are very easy integrals, I think. Sometimes I think this is more easy than basic integrals like the integral of x squared dx, because it doesn't really require a lot of thinking unless it's given in like a form like this where you have to change how it looks. So let's just do one last one. So j, the integral of 7 over 3 plus y squared dy. Alright, have a go at this one. Feel free to pause the video. Alright, so this one is obviously a tan integral, so recall the integral of a plus a squared plus x squared dx is equal to tan inverse x over a plus c, or the integral of 1 over a squared plus x squared dx is equal to 1 over a tan inverse of x over a plus c. Alright, so basically to make this look similar, we just got to take the 7 out the front. We can do that. So 1 over 3 plus x squared dy. Alright, now it's got this has the form of this one. So a squared is 3, therefore a is root 3. And we got to divide by 1 over a, so the integral of this is 7 over root 3 tan inverse y over square root of 3 plus c. Boom. Alright, so this was just a video on a bunch of inverse trig problems. If you have any questions or any specifics, just let me know in the comments. If you want to try these problems for yourself, here's a picture of them all. So we'll be covering these ones in the next video, where it's basically the same thing as doing it, except we have bounds now. Alright? So again, this video isn't a great video for learning this stuff. It's more of a problems videos, which can be argued is a great way to learn this stuff. Because it's pretty much just, with inverse trig integration, it's pretty much plug into the formula with just a little bit of critical thinking. It's problems more like this that require a lot more thought, because it requires a lot more arithmetic. Alright, thank you so much for watching. I'll see you in the next video. Thank you.